without further ado, then let me introduce club member K1PU.
PU. Thinking up the airways for 40 years. Well, so tonight's little topic of conversation is, can you compute with... Oops, come on. There we go. Of course, we need a message from our sponsor, Meriden ARC Radio Club. Oh, I have to get in line with this thing. Here we go. Yes, you can compute with fruit if it's a Raspberry Pi, that is. So what is a Raspberry Pi? Raspberry Pi is a series of credit card-sized single-board computers developed in the UK by the Raspberry Pi Foundation, which means nonprofit, to promote teaching of basic computer science in schools in developing countries. One of the co-founders, Evan Upton, came up during the years, grew up during the years of the BBC Micro. If you know anything about that in the UK, is the BBC had a learning series on one of their channels, and they had a company come up with basically kind of between a VIC-20 and a Commodore 64, 6502 processor computer, and people would buy this and they would go step by step through all the TV programs and learn how to operate and program computers. And he noticed that the skills of the kids coming into his classes in Cambridge were getting less and less and less every year. So him and a bunch of other people got together and came up with the foundation that developed this particular piece of hardware. There have been several generations of Pi released since 2012. The original 2012, and then models of the Plus variety. There was two variants, an A variant, an B variant. I'm not really going to go into the variants too much. We're just going to be talking about the bigger one, the B. And later that year, a little more capability. Raspberry Pi 2 came out, which I have some here for display. And earlier this year, the Raspberry Pi 3 came out. Also, too, another small variant, the Raspberry Pi Zero, which is a very interesting piece of kit. I have one here. We'll go over a little later. It costs $5. It's a Linux computer for $5.
Yeah.
All models of the feature a Broadcom system on a chip, which includes ARM-compatible processor, CPU, and on-chip graphics processor, a GPU. Steve will know all about this stuff. The originals ran at 700 megahertz, and the latest ones run at 1.2 gig. Onboard memory, the original ones had 512, all the new ones, except for the Zero, had a gig of RAM. Your storage medium is an SD card. On the original ones, it was a big format. On the new ones, it's the micro-sized ones. But everything, OS, everything goes on the SD card. It has a I/O header pin, which general purpose I/O pins, and it supports common protocols like I2C, SPI, it's got serial communications you can get through a terminal. All of these models have Ethernet port for 10100. Sorry, it's not gigabit, but hey, what do you want for the price? And the latest model, the 3, has Wi-Fi on board with Bluetooth 4.0, which includes a low power Bluetooth for doing all your Internet of Things gadgets. The Foundation provides Raspbian, which is a Debian-based Linux distribution for download, as well as third-party Ubuntu, Windows 10, Internet of Things Core, various other OSs, and specialized media center distributions. It promotes Python and Scratch. I'm not going to get into Scratch too much. It's the main programming languages with support for just about anything else. See, it's a Linux machine. A lot of things, all the popular packages have been ported to ARM, and they're all in the Debian repository. We'll get to that a little later. You just go into the command line, type a few commands, and all of a sudden these things start popping down, getting downloaded and installed on your machine. In February 2016, the Raspberry Pi Foundation announced they sold over 8 million devices. As of September this year, they sold over 10 million of these little contraptions worldwide. They don't make these themselves. These are farmed out in the United States. It's Newer Government 14 that distributes them, and they make it, which is Farnell in the UK.
Now we have that.
And these are made in China. The ones from the UK are made in the UK in a Farnell factory, but these are from our friends on the other side of the planet. But couple of you can tell, right, the first ones I came through, but the quality went up substantially. So why is it called Raspberry Pi? Raspberry is from an old tradition where there was Tangerine computer systems in the mid-'80s. There was a British company called Apricot Computers, which competed with Apple and PCs. Even before that, there was another British company called Acorn. Being a nut qualifies as a fruit, and of course there's Blackberries and all kinds of other computing devices named after fruit. So they chose Raspberry. Nice logo anyway. So why? Acorn is particularly relevant since they built the BBC Micro, which we talked about a couple seconds ago for the education in the BBC series. It targeted education like the ARC. It was based in Cambridge, which was down the road from where the Raspberry Pi Foundation is based. And it is the originator of the ARM chipset, Acorn RISC machine. That's what ARM stands for. Now, over the years, the company went bankrupt and they split the ARM off into a different group. But they are the ones, Acorn is the one that actually started this whole ARM thing. And the chips are used in the Raspberry Pi as well as a huge number of phones and tablets. You got a Samsung phone or you got an ARM processor there. So as easily imagined, as I said before, the fruit name was chosen because of tradition. So what is not so well known is what does Pi stand for. Pi stands for Python Interpreter. Python is a programming language. It was originally planned to equip the Pi with a built-in interpreter for Python, just like the Commodore 64 had a built-in basic interpreter. So out of the box, you get your distribution, load on your SD card, and you go through the setup process. You have a programming environment you can actually start to program with. So this is basically what we're going to go over right now, is the models and what their specs are, the features, the hardware, and the built-in software, a little bit of coding in the Pi, and what people have done with the Pi for projects, and what I've done with the Pi for projects. So here's their latest flagship model. It's the Raspberry Pi Model 3B. And it's about the size of my credit card. I have a few here we can pass around and you guys can stare and compare. Here, let's grab one. There's a Pi 2 and a Pi 3 here. But they're basically the same. It's a little dark, but you know, get out your little lights behind the phone and you can check it out. I pointed. It's 35 bucks. Bare board, 35 bucks. What you don't get a case. You don't even get the SD card. You have to buy that separate. I've been buying 16 gigabit SD cards on the way for $3.95 a piece, with the adapter to the bigger ones you can plug into the factory computer. So basically, for $4, you get yourself the memory and the ROM. And you download the OS from their Raspberry Pi website. You just literally drag and drop all the files on the SD card, plug it in, hook up all your peripherals, and you start. So it's got a quad ARM Cortex A53 64-bit processor, four cores at 1.2 gig. That's 4.8 gig worth of throughput. It's got a gig of memory at 900 megahertz clock speed. It's got Wi-Fi, Bluetooth 4.0, low and also low power. 4 USB ports. They're stacked 2 here. A 10100 network. HDMI video output. This little connector here is for a camera module they sell, both a color and a infrared. It's got a display port here, a ribbon cable. They do sell an official Raspberry Pi 7-inch display. It looks sort of like the one behind the table there. You can hook up to your projects. It's a 40-pin header with general input-output. Over that after. And a 3.5 millimeter 4-pole, just like the Yaesus, get tip, ring, sleeve. That brings out stereo sound and an analog video in NTSC format. So if you have an old TV set, with a video input, you can actually hook this up to that and get some video out of it. Not so hot on, it's a TV. You get the resolution you get.
Is the Wi-Fi antenna built on the board? Or
It's right there. It's a little dielectric antenna.
Okay.
It's got a little chip right there. A 2.4 gig, quarter wave is about that big. That thing is about the size of a grain of rice. So obviously, your range will vary because of physical limits of antennas. But in my office at home, I've got my little workbench where I do these little projects. And I got a Wi-Fi access point right in my office, so I don't really have any problems. I brought it out into the kitchen last night to hook up the projector, make sure everything worked. And I was down a bar, so I really can't complain. You're not gonna get, you know, a lot of distance out of it, but it's there. The previous model, the Model 2B, looks almost identical. You can still buy them at the same price. It's got a Cortex A7 32-bit processor, quad core at 900. You can't overclock that to a gig. It's got a gig memory at basically half the memory speed of 400. Same 2 USB ports, same 10100, same HDMI, same camera ports, display ports, and the analog here. But you may see these secondhand at flea markets and stuff, you know, and that's what the price from Newark is, $35 plus the shipping. No Wi-Fi, no Bluetooth, but still a usable piece of equipment. The streaming audio player I have here is running on a Raspberry Pi 2. This is an interesting gadget, the Raspberry Pi Model 0. I'll pass it around. The thing is tiny. It's this big. That's in the case. It's got a single core V6 32-bit ARM processor, clocked at a gig, 512 meg of memory. It's got a USB on-the-go port. It's got HDMI output. It's got a camera port. Well, this one doesn't show it, but the newer one like that. It's got it over there. It's got the same 40-pin header as all the big brothers, or all the output pins you might want. And you can get NTSC audio, video. There's a couple of pins here you can solder in and plug it in. There's no audio out on this, but you can get around that with a couple of things. What's neat about this, which I haven't had a chance to play with yet, is this USB on-the-go port. As well as adding the USB host, you plug keyboards and mice or whatever into a hub and connect to it. This also works the other way. This can be a peripheral. So you can go into what they call gadget mode. Now, for most of us who have gray hair, they've been playing with computers long enough. Back in the day, we used to use the parallel port on IBM PCs that had 8-bit data bus and a few control lines. You could program that to do all kinds of stuff. You know, on program control. So you can actually make this kind of like the parallel port days and use the GPIO output pins to do all your manipulation. So it can be a peripheral. And the cool thing about it costs $5. Now the case that's passed around costs $5. Okay, so.
Case costs 10, right?
Yeah, but now obviously all these things do not come with the SD card, so you got to invest in $4 for an SD card. But for $5, for a little tiny thing that runs a full distribution of Linux, you can't go wrong. The hardware. So this is a Raspberry Pi 3, but it's similar to the Pi 2 and the B Plus model, which you may find on some eBay sites or flea markets. But the core to this thing basically is this 40-pin GPIO header. We'll get to that in a second, the actual details, but there's 26 actual pins that are usable on this for I/O, digital I/O, 1010. Unlike Arduinos and some other single board computers that are out there, which cost more, there's no analog on this. You would have to, so if you want to do analog inputs or outputs, you would have to get your own DACs or ADCs and hook them up to, you know, USB or a couple of other pins that are on here. But for most of what I've been playing with, you know, audio is audio. You plug in a USB thing. The I/O is just, you know, digital I/O is just fine. Again, the Bluetooth 4.1, and right in this little corner here is a little dielectric antenna. The SD slots on the bottom, display port. This micro USB port doesn't do anything except for power. You get basically it's a cell phone charger. Most of your cell phones now have a micro USB 5 volts and a couple amps. Plug it in, boots, and it goes. HDMI, you can plug that right into your TV set. I plugged it right into my projector, HDMI, and it senses it. If you're going to play with these things, you can get HDMI to DVI converters. They work right out of the box. There's no fooling around. If you get an HDMI to VGA converter, you will have to play around with some of the config files to get the VGA to come up. It's just the nature of the beast. But you get a monitor with DVI, C, and D. HDMI is a superset of DVI-D. It comes up just fine. The camera, ribbon cable card slot, again, the audio and the positive video jack, your USB and your LAN ports. And here's your dimensions. If you do the metric, you see how big it is. It's about the size, internally about the size of a credit card. Slightly, a little slightly longer. The header has 26 general purpose I/O pins, and this is basically the breakout of what the header looks like. Here's pin 1. You go through real quick, you'll see GPIO, and you'll see grounds and powers, and a couple of other things, and in gray you'll see some other nomenclatures. Some of these pins can be programmed to do other things. So some pins can be enabled for special functions. One of them is the SPI interface, serial peripheral interface. There are chips and other devices that work on a serial bus, clock in, a clock, data inline and data outline, and there's 2 chip select lines. And you can enable that or disable that in the software. And if you have a peripheral that needs SPI. Next one is the I2C interface. Again, another serial interface that runs, you can program, it generally runs about 400 megahertz. Because of the internal architecture of this, you can get 120 devices in a drop bus. It's a bus architecture. You get 120 devices addressed on this, and you can go out about 300 meters, which is 1,000 feet. You can go and go and go. So you want to hook up sensors in your house. You want to see if your garage door is open. You want to check the temperature in your fridge. You want to see if your water pump's run. You could basically run a twisted pair throughout the house and just basically just do a drop to every one of these with a different address, and you can pull these things. Other things use I2C. You'll see one of my projects is the LCD display that I'm using for a project. It's a little piggyback board you can solder on the back of a standard LCD display, which does convert the I2C to the parallel bus from the LCD. And also serial communications. Like any good computer, it's going to have a serial port, so you can get on there. You can plug a USB to serial converter, plug it in, and you can get it on a console. If all else fails, you can't get anything to work, you can always get it that way and edit your configuration files through the serial port. And all these can be enabled or disabled in the configuration from the GUI if you want. If you want to use those pins for digital I/O, or you can use them for specialized. Generally, I enable these two, the serial and the I2C. I don't have a lot of SPI stuff, but that's just me. So this gives educational and hobby users access to the power of the ARPI hardware. Now, and I take it from experience, ARPI uses 3.3 volt logic. If you have 5 volt devices, you will let the smoke out of the chip. Or at best, you will destroy the pin that the GPIO is attached to. So you have to have a level shifter. So you can build one out of a FET. This is a bi-directional. This is what I use. Or you can buy a chip that does the same thing. Yeah, I like being in one world. I've got to keep my hand in the air. So please remember, 3.3 to 5 volt converters. If you're going to be doing anything with 5 volts in a bus, well, it will be a problem. Software. ARPI can run a number of different OSs. The most popular being Raspbian, which is the Raspberry Pi Foundation's derivative of Linux, and it's optimized for the iPi hardware. It comes with all the drivers and daemons and everything else that runs all the little peripherals with a system on a chip already, so you don't have to go through and figure it out yourself. And that's the logo there. The ARPI can run a number of different OSs. Most are Linux-based, some are not. So you can run all kinds of stuff. Arch Linux, there's a Chromium OS, which is the Chrome OS version of it. They have a release for that now. You can actually run the full Debian ARM release. You can run the Fedora release, FreeBSD, Kali, NetBSD, Ubuntu. I forgot to bring it. I do have a distribution on an SD card with Ubuntu 16.4 LTE, long-term LTS, long-term support that runs on there. I forgot to bring it. Windows 10 IoT core. You can put Windows, quote unquote, under that air quotes on this. It is not full-blown Windows 10. It is their Internet of Things core. And it's meant to talk back to a desktop, but it does have quote unquote Windows, and it's free. And there's more OSs here you can run that are made for the ARM processor. Also, there's some specialized media centers. There's the Libre Elect, Open Elect, XBMC. XBMC stands for Xbox Media Center. Then there's the Open Source Media Center. I had one of these running on my TVs and media center for about a year. Didn't have any problems. I was, getting files off my Mac at home and, playing movies and listening to music and surfing the internet, doing YouTube and stuff. I did switch over to an Apple TV. It was just a matter of the rentals and things were a little bit easier on that. But it full 10, the HDMI puts out a full 1080p high def signal for your TV set. It looks very nice. And that was running on a Raspberry Pi 2, and there was no problem with lag or the jitters or anything else running at 900 megahertz. Okay, we have a hardware and an OS. How do we talk to this thing? So once you load up your SD card and you get all your stuff hooked up and you go through the startup, you have two options. You can go to the purist, you can go to the command line. Remember DOS, guys?
Hello.
Well, this is
You
Linux.
speak my language.
This is Linux. Now, I'll warn you, you will have to learn some command line to do the care and feeding of this. Linux you're very close to the OS with Linux. Okay, you can hide things behind a GUI, but some things are just easier, faster, or downright impossible to do from the GUI. You will be in the command line sometime doing something. So, just to give you a warning up front, you will be seeing this occasionally. You will be in the terminal window doing a few things. But most of it is like a Windows 10 desktop. And this is the desktop for the Raspberry Pi that it comes with. This is a Raspberry Pi comes with the LXDE, the lightweight X desktop environment. It's very, again, lightweight, so it takes very few resources to run on the computer, so it doesn't bog it down. Doesn't look much different. You can change the background. You can get rid of the Raspberry if you want. You can change the taskbar from here to here or on the sides. You can customize it the way you want. But it's basically a Windows-like thing. You have a menu button here with a drop-down. You got a few things, stuck to the bar. There's a browser, the file manager, the terminal window. On the other side here, you got your Bluetooth drop-downs. You can pair devices. You have your network, which right now is showing Wi-Fi, your audio volume, little speed meter, how much your processor is being consumed, and the clock, and the eject button if you've got to remove the media. You can put things to the desktop. It's move the mouse, do your thing. And it's something that you guys have experienced in the last 20 years since Windows 2.0 came out. The Mac came out in '84. Oh, actually, at least before that. Our Pi comes with a number of different built-in applications. So out of the box, you're not dead. So here's your drop-down from the menu. You see the basics. You have a programming tab, office tab, internet, games, accessories, help, and your preferences tab. And then you have, just like Windows, you have a run tab, the little command line. You can tell it to run something. Programming tab. You have a couple, 3 different Java IDEs, integrated development environments. You can write code in Java. You got Mathematica. This Node-RED has to do with Internet of Things. I won't get into that, but it's there. You got 2 versions of Python, Python 2 and Python 3. The Python 2 is an older version. There's compatibility. There's a lot of code out there that's written under Python 2. Scratch, which is like Scratch is like a drag and drop. It's a teaching and learning environment. It's a drag and drop, and you put the modules together, and it does things. I see the utility of it. I don't use it. I know how to code it, but that's me. Sonic provides the same thing, and you have Wolfman Mathematica, and the Mathematica programs for doing something higher level things. Office, you have the whole LibreOffice suite. Everything. You got the base, the database, you got the calculator, you got the draw program, you got the Impress, which is what this is, the math and the writer. So you have a full Office suite here, and you can export to Word, you can export to Excel, and you can import from those formats. You can't do the docx or the doc process. You can't do the XML versions, but you got something you can play with. Over the internet, you have a mail client. It's okay. Raspberry Pi resources, that just brings you to the Raspberry Pi Foundation website. The Magpie, that's basically kind of like adware. They have this magazine you can subscribe to called the Magpie. And it is a web browser. HTML5 web browser. It doesn't do Flash, but it does do HTML5 video, so it's not bad. I mean, what do you want for 35 bucks? You get a lot of stuff here. And it's games. Yeah, Minecraft actually works pretty good in the Pi 3. There's a Pi version of Minecraft. My daughter, she's doing Minecraft on her iPod all the time, and she was playing with this. She goes, "Oh, it's pretty good." There's some games written in Python, so you click on that and go to submenu. There's some Python written games. Then you got the accessories. You have your standard archiver for making, tar Z files, calc, the file manager, which is nothing more than you're used to. Image viewer, PDF viewer, your task manager, so you know it's running. Again, the terminal, so you can get to the Linux raw stuff and your text editor. Now, again, being full-blown Linux, you had the VI editor, you had the nano editor, you had your bash shell. You guys know what I'm talking about. It's all in there. So extra service packages I usually add to my Pis when I'm bringing them up new or refreshing the OS to do a project. For file sharing, I install Apple File Protocol for Mac OS or SMB for Windows sharing. So here on my Mac, you see, here's the Pi right there, so it shows the home folder in my Mac. So I can develop on my Mac for the Pi, so if I'm doing things, I just move the files over. It's just a little more convenient, a little snappier, and my chair on my desk is a little more comfortable than the one at the bench, because the keyboard feels better. But that's just me. I don't have a Windows one, but you can install the SMB for Windows. It'll do the same thing. You give it a share, and it will show up in your file manager. If I need to play sounds, I install the music player daemon and the music player control program. For web server, I install Apache 2 and PHP 5 for scripting. You can run a web server on this. And for remote desktop, I install a thing called HyperVNC server. You can literally have a remote desktop. I do that right from the Mac. I just come up, I bring up the VNC viewer, I put in the IP address and what screen number I want, and it brings up a whole new screen for me in the full resolution that it'll do, and I can sit there, manipulate it, and do what I want to do without even getting out of my chair, seeing it on the lazy pole out. And all these extra packages are simple, are installed from a simple terminal command. You get in there, you play with sudo, which is super easy to do, apt-get, which means you're going to the Debian repository, you install, you tell it the package name like Apache 2 without the capital, and I just put -y, which means you say yes to all the questions, so it keeps it why all the time. And
You're lazy.
Yeah, I am. I'm really lazy. You get to know me real good, buddy. So the thing goes plowing through, and when you get to the command prompt, you may have to do some configuration. NPD, you don't have to do much. Apache 2, you don't have to do a heck of a lot to it, unless you want to change the root directory. The VNC server, you're going to have to go through and make a couple of files to tell it to start auto start when you reboot it, but there's instructions that are really easy to follow. And that's getting a new package is as simple as typing this in the command line window. So many popular Linux packages have been ported to the archive ARM and are available directly from the Debian repository in the apt-get I was telling you about. Remember, Google is your friend. If you just search with Raspberry Pi in the search term, you'll be surprised. So here, Raspberry Pi ham radio, and this is what the command just comes up, and comes up, and comes up, and comes up. It's amazing. So Google is your friend. If you don't know how to do something, you Google it. And like with Python, if you don't know how to do something in Python, you can type in Python. You say, if then else, and bing. The first one will probably be a Python manual page. Click, you're done. And that's what's good about the Linux and the open source community. It's all on the web. Nothing's hidden. If you don't know how to do something, you'll find it.
YouTube is your friend too.
Just like any other computer, it's stupid until we give it something to do. So this is where programming comes in. The ARC Pi can be programmed in many languages. C, C++, Java, Pascal, to name a few. The Pi part of Raspberry Pi is for Python. And it's built in. The whole integrated development environment for Python is there. ARC Pi comes with Python 2 for compatibility and Python 3. If you guys start any new projects, please start with Python 3. Python is similar in syntax to Java and modern basic languages. It's similar to C too, just again, it's all syntax and semantics. Python is an interpreted language, which means the program is read each time it is run. It's parsed into byte code for the interpreter to execute the program, so it's not compiled down to machine code. It goes through a couple-step process. It reads your text, make sure that the text is okay, you know, syntax and all your commas and semicolons and indents. If it's all happy, it brings it into a byte code, which is sort of machine code, but that's what tells the interpreter what to execute, what routine to execute for each one of the instructions you're given. This results in a performance penalty, unlike compiled languages like C and C++. How much of a penalty all depends on what you're trying to accomplish. If you're really looking for super speedy GUI reactions, you're looking for super speedy responses to input-output, I mean, we're talking like down a couple per milliseconds. What is the penalty? For me, I don't find it too much of a problem. But the advantage of Python being an interpreted language is the programming development environment. You're in the editor, and there's another window on the side. You're typing code in, you hit F5 to run. It goes into the run window, and it starts the thing, and all of a sudden there's an error. It pops up, it tells you the line number, and it tells you what syntax is incorrect. It highlights it in the code, so it's a very interactive development. It's cheating. No, it's not cheating. It's called development. So it's a very easy development environment. But all is not lost in regard to speed. There are third-party packages which will compile your finished Python program into an executable. And I've used them, they work quite well. And I haven't done any benchmarks, but they are standard. You don't have that intermediate step of the byte code and the interpreter running another few hundred instructions where the compiled version runs a lot snappier. But all is not lost. You can compile it with a third-party package. So this is what some of Python code looks like. It's not anything just through defs here, but Python is very picky about indentation. Let's give you a heads up on that. Unlike Java and C, there's no curly braces here to define the function. Everything is based on the indent. So here's the top level, next level, the if statement, the indent for the next level, the if statement. Come out of that, else if, the indent. So it's very picky about the indentation. That's how it knows what is going on is the indentation. And there's a few little caveats and semicolons at the end of the functions, but again, that's all easily learned all along the way. But again, it doesn't look that hard. I mean, okay, client saw a variable, if statement, if title equals, do this, if this, do that, and then we have a couple quick instructions. You click something, this is what you do. You set the volume, you bring it up by 1. If you've never programmed before, it's not that hard to learn. And it's in English, relatively. So since its introduction in 2012, Pi has developed a major hobby maker platform. And because of its popularity, and because it's designed by a nonprofit also, there's a huge, I put that in capital, a huge ecosystem of third-party companies that have developed all kinds of add-ons for Pi. Like there's cases, and you float around, and all those cases are made by third parties. LCD displays, I got one here. You can have LCDs, LEDs, OLEDs. You can have them from this big to this big. Accessory ports, what they call hats. There's a hardware attached on top. That's how they do it. Sound cards and DACs, proto boards you can fit on the connector that have the breakouts for you. It goes on and on and on and on and on. Again, Google is your friend. Now, what more can we do with this stupid thing? Well, it follows is just the tip of the iceberg. It's only a few things I selected out of the bunch, but again, Google is your friend. The thing to do, you'd be amazed. And the YouTube videos, it's just hours and hours of YouTube videos, how to do things, how to make things. So anyway, there's a few projects other people have created, and most have a handwriting. So here's a Raspberry Pi to Spectrum display using an inexpensive RTL SDR USB receiver. That's this thing here in the back. You get them on eBay, $10. You plug it in, there's somebody wrote the software. This is actually a Raspberry Pi 1, which is 700 megahertz and 512 mega RAM, single core. And it's running FFT. You can see that it's in the FF band. You're seeing a waterfall display of the spectrum. So, just to give you an idea how powerful even the old one, I can tell because of the RCA connector, that's where the video came out. And that's on a very small LCD display. You can buy these 30 bucks. It's right on top. FLDigi. FLDigi is a program you can buy. It's free. It'll run the Raspberry Pi in ARM. You can hook it up to your radio through the serial port or through USB, and with the sound, with a better sound card. Now I'll give you this. The sound that comes out of the Raspberry Pis is sound. It's a little hissy, a little white noisy. It's because they don't have an onboard dedicated DAC, on there to make the sound. What they actually do is they take two of the GPIO pins coming out of the Broadcom system on a chip, which aren't broke out to the 40 pins, and they pulse width modulate them at 50 megahertz, which basically they send an FM out for each channel at 50 megahertz. They demodulate the FM and they run it through a few RC filters. It works, it gets your sound out, but it's a little hissy and it's not the best quality, but it'll do the job. So I do recommend getting a little USB sound board. What I have here is C Media CM108s. They're $10, $12 on eBay. They sound real good. But you can put this on your Raspberry Pi, run it full screen. You can control your radio. You can decode PSK, CW, RTTY, send, receive, any of the modes, and have that as your little rig controller. And you can even have a logging program on the side too.
How much power is this machine using?
It needs a 2 amp supply. If you look on the web, it'll give you all the different power consumptions. The more USB goodies you plug in, the more it's going to draw. But I think it's about an amp. The new one's like an amp total, for everything. So you can actually put this on a Pi with a little 7-inch display like I got there, keyboard, mouse, and you can have a little rig controller for your QRP radio. Everything's small. TNC Pi. Somebody in the UK came up with a whole Kisco TNC for your Raspberry Pi. It connects right on top of your Pi to the GPIO pins. You can either have one of them, or you can have a whole slug of them, because this will run an I2C bus. So you can address them all different. You can have multiple TNCs running on the Pi. All the major packages, F6 FTD BBS, AR cluster, what's the other cluster?
What's that?
What's the AR cluster? What's the other one? DX Spider. Sorry, DX Spider program. It's all been ported. It's all been ported to ARM, so you can actually run a cluster. Yourself. You can plug it in the internet, get into the main database for the cluster. You can put this in on a radio, and you can have a packet cluster on the air. You can stack these things up 120 if you wanted to. Why would I? But you could.
Now, can you select the speed of the interface?
I2C is fixed.
Pardon?
I2C is fixed. You don't have to worry about it. It's all.
Plus.
I use this a lot at work. People ask me how things work. I tell them it works by FM. Friggin' magic. But again, somebody came up with a KISS TNC. You can mate it to the Pi with the appropriate software, which is all free and downloadable. You can configure it. You can run the PBS. You can run a DX cluster node. Whatever you want, it's out there. Because AX25 protocol is part of the Linux distribution. Now, a couple of my projects I built. This is a school alert system I built for the Portland school system in their high school, middle school. What this does is it hooks up to their phone system, and they get on a dial code, and it throws a relay contact. And these two contacts here are a relay contact, and it sets the world in motion. What it does is, I'll show you the next slide after. It disconnects their intercom PA system from the real world and hooks it direct to this. It dials the appropriate code, access code to get into it, and it plays a pre-recorded wave file, which on this happens to be an alert tone. And when that's over, you have live audio from the phone that they activated. They can do their lockdown alerts or their drill alerts from it. This has a GUI with it. You can plug in the keyboard and the HDMI and and you can program it from there. This also has a web interface, so that the school security officer just gets, on his web browser, types in the IP address of this, which is right there, and bingo, he logs into it, and he can control all the parameters and functions and upload WAV files and whatever he wants to do through a web interface, which is running Apache 2, PHP, and another program called Wiring Pi, which I won't get into. That controls the I/O from the web. So here's with the cover off. Here's your Raspberry Pi. Here's the 40-pin header going here. Here's my proto board because I was too late. I know they want to make a PC, have a PC board fabricated for a one-off. But this is all the analog circuitry, transformers. I'll hook up the phone equipment. This is a little optocoupler here. So if you're using a line port, you can click it, and it's got telephone value. You guys, telephone guys know telephone value. You pick a loop current. A couple of amplifiers. One is just for the local speaker here, and the other one is for the audio gain. Audio gain through the system. This little cot here is just the audio gain for the Raspberry Pi audio. On this particular one, I use the audio here because this paging audio going to a school. It doesn't have to be hi-fi. 44.1 sampling, so it doesn't really matter. And the Ethernet connection. And it's got a bunch of status lights in front when it's doing different things, flashing, loading. And the LCD tells them what the time is, it's ready, and what the IP address is, so they can actually figure out how to get into the thing. And that's it installed. So one of my customers, I do need work. Another one is the internet streaming audio player. Seeing BBC decided to get rid of their Antigua broadcasting facility. You can't get BBC on shortwave anymore. The only time I can hear is either in my truck on XM radio or wait till after midnight on WNPR here and the local NPR affiliate. They put BBC on at midnight. So, I like to sleep. So, BBC streams. BBC streams everything. They stream the World Service. They stream all the radio services, Radio 1, Radio 2, Radio 3, 4, 5, plus the extra channels. They also stream the regional channels that they have for Wales and Scotland and Nottingham and the Midlands and the North. They stream everything. So if you really want to do it, so I built this little thing, Raspberry Pi, a couple of powered speakers from back in the days when I had a Windows box. Wrote a Python program, wrote the GUI for it, put it on a 7-inch touchscreen. I need a bugger. There isn't much hardware involved. I mean, it's just a Pi, little wireless dongle. Here's the USB audio and the connection with the power, the connection that goes to the screen. It's all software driven. And here's what the front of the GUI looks like. Now, this isn't drag and drop stuff. You're not playing with like Windows.net. You actually have to hand code this. You got to tell it in code what the thing is. It's a button. You got to tell it where it's going to be. You got to tell it how wide, how high. Where the top corner is. You got to tell it what the text is. You got to tell it what the image is. You got to tell it that the text is going to be on the bottom of the image, not the top of the image, not the middle of the image. So, this is not drag and drop. It's hand coded, but there are packages you can get. They don't run on the Pi itself. They will run on your Windows PC or on your Mac. One is called Lazarus, which is a drag and drop GUI builder, which works in conjunction with Object Pascal. You can another one called Zojo, used to be called Real Basic. They have. It's a little pricey. I have it because I do develop for the Mac and stuff, but they have an ARM option, Raspberry Pi ARM option, where you can compile your drag and drop all your code, compile it to an executable file for the Pi. So there are other options to develop for it than actually on the Pi itself, and you just, again, you can either FTP to it, or you can do the file shares like I showed you before, the AFP or the SMB, and that's all I do. I just go, I drag it, I drop it into the folder if I want. Your life is good. So I hope this brief overview has inspired you to unleash your creativity with the Raspberry Pi. So question time. I've never seen this group so quiet. Thank you very much. I've got demos up here.